So to finish up this unit, we're going to talk a little bit about slopes of parallel and perpendicular lines. I would imagine that this is something that you did in Algebra 1, although I don't know for sure. But it's something that is a geometry idea. So just a quick reminder of the slope formula. If you have 2 points with coordinates x1, y1, and x2, y2, then the slope of the line is y2 minus y1 over x2 minus x1. It's the change in the y coordinates over the change in the x coordinates, or the vertical change over the horizontal change. Do you guys ever use deltas in science for the change in something? Yes? So delta y over delta x. The change in y over the change in x. When you get to calculus in a few years, what you do is you go beyond this, and instead of a big change, you do a little change over a very small interval, and you have dy over dx. But that's something to look forward to. Anyway, so let's find the slopes of these. We're going to do this really fast. So the slope here, I always pick the bigger y value to start with so that I'm likely to have less negativeness. So 7 minus negative 9 over negative 3 minus 4 is 16 over negative 7. And you're welcome to leave it that way. Just as a reminder, 16 over negative 7 is the same thing as negative 16 over 7 is the same thing as negative 16 sevenths. All of those are equivalent to one another. Yes, sir?
Wait, I'm confused because isn't it the second x comes first, so wouldn't it be 4 minus negative 3?
Well, notice I started with this one. So what I've done is I've called this x2, y2. Does the order matter? Well, let's check. What if I did it the other way? What if I did negative 9 minus 7 over 4 minus negative 3? Be negative 16 over 7. So what's important about the x's and y's, Kyle, on that is that these two have got to be out of one point and these two have to be out of the other point. And it really doesn't matter because think about it. Couldn't I have given these to you in the opposite order? Yeah, it wouldn't make any difference. Okay? It's a good question. All right, and then for this, the slope would be negative 3 minus negative 3 over 8 minus negative 2 is 0 over 10, which is equal to what? 0. Now, oppose that to this next one. Here the slope would be 11 minus 2 over negative 5 minus negative 5. And that's 9 over 0. What's 9 over 0 equal to? I'm sorry? No? No? Pardon? It's not 9. Well, let's talk about fractions for just a moment. So let's say that you have 3/4 of something. I'm going to take you back to elementary school and go, okay, draw 3/4. And you went, okay, I'm going to take my little circle and I'm going to divide it up into 4 parts and I'm going to shade in 3 of them. That's 3/4, right? Okay. 0/10 means that you took your little circle and you divided it into 10 equal parts. Yoinks. I'm trying to picture this in my head before I do it. Pretend that those parts are equal. Ian is judging me based on how well I was able to do that. And how many of them do I have shaded in? 0. Now, what this says is draw your little circle and divide it into 0 pieces. How can I divide that circle into 0 pieces? Pardon? You don't draw. Yeah, you don't have anything. It's not that you have 0, it's that you can't even start it. This is undefined. So there are a lot of things in math that at one point or another you were told you can't do that. And it wasn't so much that you can't do them, it's that you can't do them yet. For example, when you were very young, someone said, oh, you can't take 6 from 4 because 6 is more than 4. Well, can you take 6 from 4? Yeah, you just had to have a different kind of number that you weren't ready for yet. You had to have -2. Or someone probably said at one point, oh, you can't divide 2 by 5 because, 2 is smaller than 5. Well, yeah, you can. It's 2/5 or 0.4. At this point, you've probably been told you can't take the square root of a negative number. You will find out, I think it's next year, that there's a whole nother class of numbers where you can take the square root of a negative number. You just weren't ready for it yet. Okay? But in all of math, the one thing that you're never allowed to do is divide by 0. You're never allowed to divide by 0. It is undefined. It doesn't make any sense at all. The closest thing that you could get to that would be, well, how many times does 0 go into 9? Or you could spend all day putting zeros into 9 and not get anywhere, right? The closest thing would be to say that it is infinite. But infinity is not really a number. So anytime you've got 0 in the denominator, that's a problem. And that's going to come up a bunch over the next several years for you, not so much in this class, but in Algebra 2 and in Pre-Cal and in Calculus. 0 in the denominator means the function is not defined at that point. And again, that's just going to come up over and over and over and over again. All right. So that's a review of stuff that hopefully you already knew about slope. Now the next thing, if 2 lines are parallel, they have equal slope. So this problem, find the slope of any line parallel to the line containing the coordinates -6, 5 and -12, -3. Okie dokie. So I'm going to find the slope of the line that I have now. So I'll do 5 minus -3 over -6 minus -12. And that's going to be 8 over 6, which is 4/3. So the slope parallel to that will also be 4/3. And I think that makes sense, right? If two lines are going to be parallel, they need to be angled the same way. They need to have the same slope. What's not as immediately obvious is the next thing, which is if two lines are perpendicular, then their slopes are opposite signs and they're reciprocals of each other. Do you guys remember what reciprocal means when you're talking about fractions?
No.
Lariah said yes.
It's when you flip it.
Yeah, you just flip over the fraction. That's the reciprocal. So here, let's find the slope of a line perpendicular to the line containing the points -7, -8, and 3, -4. So the slope of the original would be -4 minus -8. Like I said, I always start with the larger y first, but then I have to start with 3 minus -7. So that'll be +4 over +10. Always reduce your fractions before going on. So that's 2/5. So the slope of the perpendicular, I'm going to change the sign, so it'll be negative, and take the reciprocal, it'll be 5/2. So here's another kind of question that you'll get. Given the following points, are lines A, B, and CD parallel, perpendicular, or neither? So I need to find the slope for each of those lines. And when you're finding things like this, you want to identify what it is you're doing. So the slope of line AB, notice this is one way that you could indicate that I'm finding the slope of line AB is to use that AB as a subscript. Kyle, you with me? You're not with me. You need to be with me, okay? If you're on a different page, you're not with me. If you just find slopes, I'm going to be like, I don't know what the heck you're doing. So label them clearly as to what slope is which in some way or another. So I'm going to do -2 minus -6 over 7 minus 10. That would be 4 over -3. The slope for CD is going to be 8 minus 5 over 0 minus 4. That's 3 over -4. So are they parallel, perpendicular, or neither?
Parallel.
They are neither. To be parallel, they have to be the same, and they're not. And to be perpendicular, they have to be opposite signs and reciprocals, and they're not. Remember, it has to be both. All right, let's go on to page 3. When you have a graph, the simplest thing to do is to use lattice points to simply count the slopes. So, for example, for finding the slope of line A, here is a lattice point, that is where the line goes through the corner of your grid, and here's another lattice point. You don't have to necessarily draw in the triangle, but that's the slope triangle, where this is 1 and this is 3. So the slope of line A is 1/3. The vertical change is 1, the horizontal change is 3. And notice that the line goes up as it goes from left to right, so the slope is positive. For line B, well, what kind of slope does this line have?
No.
0. It's neither going up nor is it going down. for line C, be careful of things that aren't quite lattice points. Like look at this one right here. Do you see how that doesn't quite hit the corner? It's real easy to look at it too quick and go, oh, that's a lattice point. It's not. This is a lattice point here. And the next one is not until we get all the way down here. This is a near miss here at the x-axis also. So this goes down 1, 2, 3, 4, 5, 6, 7, and to the right 4. So that's -7/4. And then what about line D? Pardon? No. 2 would mean that we have a vertical change of 2 when we have a horizontal change of 1. Right? Here we never have a horizontal change, do we? So no matter what 2 points you pick, this would be 3 over 0, which is undefined. And for slope, the way to think about that is, this is so steep that we can't give it a numeric value, right? It's perfectly steep. All right, so how about this? Any line parallel to C. The slope of C is -7/4, so a line parallel to C would have a slope of, I'm sorry, I heard lots of yeah, -7/4. All right, what about a line perpendicular to A? The slope of A was 1/3, so perpendicular to that would be, yeah, -3 or -3/1. I'm happy with either one of those. And a line perpendicular to D,
0.
yes. A line whose slope is undefined is perpendicular to a line whose slope is 0. All right, here they want us to graph the following lines. We want to graph a line that has a slope of 3/4 that passes through the point 5, 1. So 1, 2, 3, 4, 5, 1. And the reason I wanted to do this particular one is the slope is 3/4, but if I count up 3 and to the right 4, I'm all the way off the grid, right? But 3/4 is equal to -3 over -4, right? Because a negative divided by a negative is a positive. So I can also go down 3 and to the left 4. All right, for this next one, we want to have an undefined slope, and we want it to pass through the point -5, -2. So here's -5, -2. And a line with an undefined slope is,
Straight down.
yeah, what's the word for that? Vertical, yeah. And I guess since it called that point A, I should probably call it what it called it. For number 3, passes through the point P at -2, 5. And would be perpendicular to a line through L and K, where L has coordinates 10, 2, and K has coordinates 4, -2. You don't need to graph this line. You just need to find its slope. So again, when I'm finding the slope of a particular line, I'm going to label it. The slope of LK would be 2 minus -2 over 10 minus 4. That's 4 over 6, which is 2/3. So what's the slope perpendicular to LK going to be? Yeah, -3 over 2. So we'll move from P down 3 and to the right 2. And then especially since I'm not using a ruler here, I want to put plenty of points so that I can try and hit them all. And the same idea on this last one. We're passing through the point 3, -2. Didn't give a name for that point, so I don't have to put anything. And I want it to be parallel to the line RT. So I'm going to find the slope of RT. So that'll be -7 minus -19 over 5 minus -11. Let's see, that's going to be 12, and this is going to be 16. So that's 3/4. So the slope parallel to RT is going to be what? Also 3/4. 1, 2, 3, 1, 2, 3, 4. Barely fits on there. But I can also go down 3 and to the left 4. And that'll be on the same line. Any questions about that? Okay. Going to make Ian happy again.